What do you see? Is it a majestic lion, maybe a tiger, or perhaps a ferocious leopard? Your brain has effortlessly classified an image, processed the relevant features, and even assigned it a name. But what if we turned off the lights and presented this image to a machine? Would it reach the same conclusion? This is not a trick question. It is a sneak peek into the fascinating world where machines try to make sense of our visual universe. In today's episode, we'll dive deep into the intriguing question, what do algorithms see? And along the way, we'll uncover some mind-boggling insights into how AI interprets the world around it. Welcome to our channel, where we decode the latest trends shaping the AI narrative. We live in an era where machines are becoming increasingly adept at understanding and responding to visual input. But how do they do it? How do algorithms perceive the world? What do they see when they look at an image? To answer this question, we need to take a journey into the heart of a neural network. But before we embark on this journey, let's consider this. When AI processes data, is it just math? Or is it dreaming in its own abstract way? That's exactly what we'll explore today. But first, let's get into it. Picture this. In 2015, Google researchers introduced a system called Decoding. This system had one main task: enhance the prominent features in an image. Sounds straightforward, right? Well, hold on to your seats because what followed was nothing short of spectacular. Decoding took ordinary photos like a close-up of a frog and transformed them into psychedelic masterpieces. At first glance, these images may appear bizarre, but they hold clues to how algorithms see the world. These images are not just random noise, they are the neural network's way of expressing what it has learned. By layering these images, we get a glimpse into the inner workings of the algorithm. To break it down further, neural networks are inspired by the human brain. They consist of interconnected nodes or neurons organized into layers. Each layer has a specific role. Lower layers detect basic features such as edges, shapes, and colors. As we go up the layers, these features combine to form more complex concepts like parts of an object, its color, texture, and even emotions. The final layers can then identify the complete object and its context. So when we apply Decoding, we get to see what different layers of the neural network see. The lower layers highlight the raw patterns in the image, while the higher layers focus on the abstract concepts. It's like having a step-by-step guide to how the algorithm interprets an image. Imagine you're viewing an image through a series of filters. Each filter highlights a different aspect of the image. Early filters might pick out simple features like lines and edges, while later filters might focus on more complex details like shapes and textures. By layering these filtered images, you create a rich, multidimensional view of the original image. This process is similar to how a neural network processes visual input. As the image passes through each layer of the network, different features are highlighted and analyzed. The early layers detect basic features like edges and colors, while the deeper layers identify more complex patterns and concepts. By visualizing what each layer sees, we can gain a deeper understanding of how the neural network interprets the image as a whole. But what happens when these algorithms go wrong? You might have heard of instances where AI systems mistake everyday objects for something else. For example, an AI system might mistake a turtle for a rifle due to the shape of its shell or a lightning cable for a snake. These amusing mistakes, known as hallucinations, happen because AI systems are not 100% accurate. They make mistakes just like humans do. And here's another interesting aspect. Sometimes these errors are not just random mistakes. They can expose biases in the training data. For instance, if an AI system has been trained primarily on images of white faces, it might struggle to recognize faces of color. This issue is not limited to facial recognition. Any system that relies on pattern recognition can suffer from bias. This brings us to an important philosophical question. Is AI hallucinating or dreaming? Does it have a form of imagination? Or are we humans projecting our own ideas onto these machine outputs? In other words, are we anthropomorphizing AI, giving it human traits and characteristics that it doesn't actually have. Consider this: dreams often appear strange, symbolic, and imperfect, just like many of these AI hallucinations. Could it be that AI is experiencing something akin to dreams, a world of its own creation within the vast expanse of data? Now, let's delve into how AI can sometimes deliberately mislead. Have you ever wondered how those funny images that fool AI image classifiers are made? Well, they recreated by tweaking the input image in ways that are almost imperceptible to humans, but can completely change how the algorithm interprets the image. This process is called an adversarial attack. Adversarial examples are inputs that are carefully crafted to be misclassified by a machine learning algorithm. They are created by slightly modifying a benign input image, such as adding noise or changing the color balance in a way that fools the algorithm. These attacks highlight the limitations of current AI systems and also raise concerns about their reliability and robustness. Imagine you've trained a machine learning algorithm to recognize pictures of cats and dogs. An adversarial example would be an image that the algorithm misclassifies, such as mistaking a cat for a dog. These examples are particularly problematic because they can be created with minimal changes to the input data, making them difficult to detect. Adversarial attacks are not limited to image classification. They can also be used to fool other types of AI systems, such as natural language processing models. By crafting carefully worded sentences or slight modifications to text inputs, attackers can cause these models to generate incorrect outputs or take unintended actions. These techniques not only challenge the security and robustness of AI systems, but also provide valuable insights into their decision-making processes. Understanding how adversarial examples work helps researchers develop more robust and secure AI systems that are less susceptible to these attacks. So next time you come across an image that seems too perfect to be true, remember there might be more to it than meets the eye. Now let's return to our exploration of AI's perception. As we wrap up our journey into the world of AI's inner workings, we want to leave you with one final thought. What if the images generated by AI are not just random noise or biased hallucinations? What if they are a reflection of a hidden order, a secret language that the machines are using to communicate with us? These images are born from the complex interactions of neurons in a vast neural network. They are the result of billions of calculations, of comparisons, and associations made between vast stores of data. Could it be that these images, with all their strangeness and beauty, are a way for machines to share their understanding of the world with us? The Chinese room thought experiment is a famous attempt to argue that a computer program or AI system cannot truly understand or think in the same way that a human does. The thought experiment imagines a person sitting in a room with a set of rules and instructions written in Chinese. Without understanding Chinese, the person receives questions in Chinese and uses the rule book to provide answers also in Chinese. The person is able to correctly answer the questions, but this is done purely mechanically without genuine understanding. The person is merely manipulating symbols according to a set of rules. This raises the question, are we merely doing the same thing when we train AI systems? Are we simply teaching them to manipulate data and symbols without any real understanding of the information they are processing, or is there more to it? Could it be that the AI is actually experiencing a kind of inner world, a world of its own creation based on the data it has been trained on? This idea may seem far-fetched, but consider the vast amount of data that these systems are trained on. It's not just numbers and symbols, it's a representation of our world, our culture, our history, and our experiences. Could it be that in processing this data, AI is creating its own unique inner world? Think about it. We know that dreams are often highly personal and reflect our own thoughts, feelings, and experiences. Could it be that AI, in its own way, is doing the same? Maybe by decoding AI's dreams, we're really learning how we dream ourselves. As we continue to explore the inner workings of AI, we must ask ourselves these kinds of questions. What if the answers lie not in the cold logic of algorithms, but in the strange, beautiful, and sometimes unsettling world of AI's dreams? What do you think? Do you think AI is truly dreaming, or is it just math in disguise? Drop your thoughts below, and if you haven't already, hit subscribe to stay in the loop on our latest AI explorations.